Let's do a second example with position, velocity, and acceleration. Examples of this sort are less intuitive because there isn't any physical situation behind it, but they're a pretty classic type of problem. So, example. An object moves along a coordinate line. We've got a position function, s of t. It, as any position function does, measures the object's distance from 0 on the number line. And even though we're not attaching a word problem to this, let's give this a unit. Let's measure distance in meters. T in seconds. Just so that when we talk about velocity and so on, we have units. So in particular, let's let s of t be quadratic. And let's limit the time this object moves. Let's restrict t on the interval from 0 to 2. And we'll do each part of this we'll state a part, then we'll do it, state another part, then do it, and so on, rather than state all of the parts of this example at once. So part A will be to find the body's displacement and average velocity between 0 and 2 seconds. So this is not a calculus problem. The displacement is just s of 2 minus s of 0. Let's see, 2 squared is 4, plus 2 is 6, minus 6. 0 minus 2. So the displacement is negative 2 meters. That's not the total distance the object moves. You just take where the object started and you take where it ended up and you subtract them. And the average velocity is the displacement divided by the length of the time interval, or -1 meters per second. B. Let's find the object's velocity, acceleration, and jerk at the beginning and end of the time interval we're looking at. So at 0 and at 2. Velocity, we'll just do these one by one, is the derivative of the position function, which is 2t minus 3. Let me just, since we can't see the entire paper, scratch down the interval here for future reference. So at the beginning of the interval, the velocity was -3 meters per second. At the end of the interval, it was moving at 1 meter per second. The acceleration is the derivative of the velocity. Acceleration was then constant, 2 meters per second squared. So at the beginning and, oops, sorry about that. At the beginning and at the end of the interval, now acceleration was constant. And the jerk tells you how the acceleration changes. Constant acceleration, constant jerk, jerk of 0. And again, the way this is phrased, it's asking what happens at specific time intervals, but the jerk is always 0. I think a little more interesting, the next question asks, when, if ever, does the object change direction. And we can investigate this question by looking at velocity. Let me copy it down. The velocity is 2t minus 3. And remember that velocity is signed. It can be positive or it can be negative. Indeed, we see those both. The velocity is initially negative, then it's positive. And the sign of the velocity is telling you which direction the object's traveling in. It can be traveling in the negative direction, or it can be traveling in the positive direction. So if the velocity changes sign, it must also change direction. And when does it change direction? Well, at the moment that it changes sign. So when does the velocity change its sign? The velocity is a linear function with a positive slope. It has a y-intercept of -3. It changes sign from negative to positive here at the x-intercept. So after 3/2 of a second, it changes from going left or going in the negative direction. I've drawn a horizontal number line from going left to going right. That's it for the parts of the example, but let's talk about this a little more. It can be, I think, confusing if you don't think it through. The object is initially going left at a speed of 3 meters per second. It slows down as it moves to the left. At the moment where it changes direction, its velocity is 0. So as it moves to the left, it's slowing down, it comes to a standstill, then it starts moving to the right, going faster and faster and faster. during all that time, this object's acceleration is constant and positive. So as the object slows down, it's accelerating. And this can be unintuitive until you remember that your velocity is assigned. So your velocity is initially -3, but it's increasing due to acceleration as the object's velocity increases, its speed decreases. So when the velocity goes from -3 to -2, that's an increase in velocity, but the speed is decreasing from 3 meters per second to 2 meters per second to 1 meter per second, and then finally it stands still. So the object is always accelerating. Its velocity is always increasing at a constant rate. But initially, that causes it to slow down. It's perhaps a little unintuitive.